Bismillahirrahmanirrahim. So today, inshallah, we are going to discuss about two topics. The last topic of work in the power chapter, that is power and efficiency. Now, power is something related to time. We already informed you that whenever we are talking about energy and work, we are not actually concerned how much time we are taking to complete the work, right? The energy or the work, the amount of work does not depend on time. But if I ask you what is the power of a certain person, that definitely depends on time. Very important for MCQ, okay? Must remember. So the rate of doing work or energy transfer. Why I say doing work or energy transfer? Because doing work is equal to the energy transfer, right? Okay. So the rate of doing work or energy transfer with respect to time, okay, with respect to time is called power. Now, for example, if I say that in 5 seconds someone did 50 joule of work, then in 1 second, how much work he will do? 50 divided by 5 is 10 joule per second. Right or wrong? 10 joule per second. 50 joule and 5 seconds, so 10 joule per second. This is power. So you can see that to calculate power, we divide the amount of work done by time taken, T. That is why T is equal to W divided by T. The unit of power is watt. Okay, sometimes it is also measured in kilowatt, and there is another unit of power, that is horsepower. 1 horsepower is equal to 746 watt. And what is the dimension of it? If you know the dimension of work, then it is easy. The dimension of work is m L square T inverse 2. Now, as I'm dividing by another time, so what it should be? M L square T inverse 3. This is the dimension of power. Okay? Achha. Now, we will try to establish a relationship between power and force. Power, force, and velocity. Okay? As I already showed you that power is equal to work divided by time, and work is equal to force into displacement divided by time. Okay, work is equal to force into displacement. Now force is there, but S by T, this displacement by time, that gives us velocity, right? So power is equal to force into velocity. We can write this too. That is equation 5.31 in your textbook. Okay. So this equation is sometimes put into use to solve numerical problem. Okay. Acha. Then okay. What? Okay. Sometimes you will be asked for 2 marks question. Okay. You will be asked what is the significance of 50 watt? What is the significance of 50 watt? Now how can you answer that? 50 watt means 50 joule per second. Okay, watt and joule per second is the same. They are the unit of power. Okay, so 50 joule per second, what does it tell you? It may be 50 joule by 1 second, right? 50 joule per second, or I can write 100 joule in 2 seconds. Okay, so I can write many ways like this as long as the answer is 50. 50 divided by 1 gives you 50, 100 divided by 2 gives you 50, right? So as long as the answer is 50, I can write so many things. Okay, so how to write it in words? You can write it in words in this way. If a person is doing 50 joule of work in 1 second, then the power of that person is known to be as 50 watt. Or you can write if some person is doing 100 joule of work in 2 seconds, then the person is supposed the power of that person will be 50 watt. Okay. Or you can write it in this way that if a person is transferring energy of 100 joule in 2 seconds, then the power of that person is 50 joule. Okay, you may write it in so many ways if you understand the basic. Is it clear? Do I need to write it, the full answer?
No.
Okay. Mm. Acha. So can I move to the next topic, that is efficiency?
Okay.
These are actually, you already know. Efficiency. Remember it by OE. O means
Output energy by input energy.
output by input. Okay, many make the mistake, they put input in the numerator and output in the denominator. Be careful. Now, output, it might be energy. If it is output energy, then you have to divide it by input energy. But sometimes in the question, not the energy, but the power will be given. So at that time you can write output power divided by input power. Okay, into 100%. If you want, mostly we express the efficiency in percentage. So if I express it in percentage, then I have to multiply by 100. Okay. Awesome. So now this is what we know till now, right? But we can write another expression for it in this way: total effective energy. That is actually output energy. Whatever energy you are getting as output, that is the effective energy, divided by total supplied energy. Whatever you supply, that is the input for the machine. Into 100%. Okay. So sometimes you will be asked to calculate the total effective energy. Now, if you don't know what we mean by the total effective energy, then you will not be able to calculate, right? So please remember, total effective energy means the output energy, and supplied energy means the input energy. Hmm. Okay, I think we're done with the chapter. And I told you to go through the numerical example from number 1 to 15. Did you go through?
মনে
No.
ছিল না একদম।
হ্যাঁ, মনেই ছিল না। Okay. Normally Sadia does. Sadia, did you?
আমি করি নাই।
স্যার আজকে বিকালের মধ্যে করে ফেলবে, একদমই মনে ছিল না।
বিকালের মধ্যে করলে এখন কিভাবে কোশ্চেন আস্ক করবা বলো? আচ্ছা ঠিক আছে, অসুবিধা নাই। তোমরা জাস্ট এমনি দেখো কোশ্চেনগুলা আর আমাকে বলো যে স্যার এটা একটু সলভ করেন, এটা দেখে মনে হচ্ছে যে একটু ডিফিকাল্ট।
ওকে।